The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and good morning to my colleagues on the West Coast. I'd like to introduce you to our drinking water policy webinar this afternoon. My name is Alan Roberson. I'm Executive Director of the Association of State Drinking Water Administrators, and I'm going to give a short intro to drinking water policy before we move to our primary presentation. My presentation is pretty short. The real content is in the research conducted by Dr. Allaire that we'll hear about later. But I'm going to talk about why we need more drinking water policy research now, some of my past policy research, some recent research that we did on the lead and copper rule, and then some policy research that was conducted by summer interns when I worked at the American Water Works Association for many years, and then finally conclude with some recommendations. So I started at the American Water Works in 1991, and as I was working in the weeds of the regulations, I started asking questions. I think it must be my engineering background trying to figure stuff out. And I found out there was really limited research on these critical questions, such as how effective are the regulations? Are we regulating the right thing? And then what might be the impacts if we have future regulations or revised ones that we have? So it's kind of an interesting political environment, to say the least, in DC right now. And the current regulatory slowdown, I think, provides an opportunity to conduct some of this policy research. It could help us target our opportunities for future regulations so that we maximize that risk reduction. If you think about what's happened in drinking water over the last 20, 30 years, we've regulated a lot of the low-hanging fruit. We've reduced some of the bigger risk. So the future regulations will be reducing even smaller risk. So I went back and just looked at some of my publications and some of the old resumes that I had. And I remembered the first policy paper that I published in the Journal of the American Water Works Association in 1995. And this was a compilation of numbers that came from the first negotiated rulemaking on disinfection byproducts. And really my intent was just to collect all the discussion and technical analyses that were done in 1993 and put it all in one place so that people could understand where these numbers came from, where the MCLs came from, and where we developed our understanding of what enhanced coagulation and enhanced softening look like. And then as I continued to work there, I had other topics pop into my head, and the ideas began to broaden, but they were primarily used to feed into EPA's regulatory development process. So I looked at compliance statistics. I looked at the contaminant candidate list. For those that aren't familiar with that, that's something that came out of the 1996 amendments, where on a 5-year basis, EPA is required to make a list of contaminants of concern, contaminants you're going to think about for potential regulation. I've got an example of some of the policy research that came out of that effort. And then one paper on uncertainties in microbial methods, and then a whole lot of others. And then, you know, I had this great idea that, you know, someone else could do the work. You know, I could have the idea and just didn't have the bandwidth to do all the data collection and analysis. So let me start a summer internship, and then we could collaborate on these papers and get them published. So this is one of the papers that I worked on, and it's kind of busy, but let me just try and explain it, because it was a concept. Again, I went back and looked at some of the publications and found that starting in 2007, this was a topic to try and look at how you might sort out all the contaminants in front of you and develop this two-dimensional matrix of occurrence and toxicity with, you know, increasing toxicity as you go from 1 to 10, and then increasing occurrence from 1 to 10 on the x-axis. And then we came up with these low and high risk bins, and then kind of a gray area in between. And this was originally literally sketched out on a lunchtime napkin at one of the water quality technology conferences that ASDWA did. So we came up with this conceptual idea of having this kind of graphical presentation of a lot of data. And then really every 3 years, I'd collaborate with other people and some academics, and we put out a series of papers in 2007, and then 2009, and then 2012, and then 2015. So I'm kind of ripe for a new paper, but haven't done it yet. So this is from the 2009 paper that I collaborated with an academic and one of his students. And we're trying to take a look at how you might take into account where you have a variety of data. In this particular case for CCL3, we had project data and we had EPA data. And then we used different sizes of these circles and the triangles to try and indicate the quality of the data. And so you're having to make some judgment calls, depending if it was a peer-reviewed publication, or that might be in the gray literature, or something that was maybe even less relevant. And these bins, the 1 through 10, were really based on the bins that EPA set up. For example, for occurrence, for toxicity, you'd have either a reference dose or a low L or a no L. And those bins, we followed what EPA set up when they were looking at CCL3 as part of their contaminant information sheet. So again, this was a graphical way to present all the data. You can see the solid circle and the solid triangle that weights, that sort of weights all that data together. So you can see, again, even across this span of data for occurrence, which goes from 1 to 10, how the weighted data ends up more on the high side. So again, this is the way to try and graphically represent a lot of data. Then you could compare different sheets to try and figure out what should be on a future contaminant candidate list. Kind of an interesting way to look at a lot of data on one graphic. So then recently, in response to EPA's federalism consultation on the lead and copper rule, EPA held a meeting on January 8th. They wanted input from state and local officials and other water organizations. They developed a series of questions on 5 major topics and gave us 60 days to develop comments. And so our challenge was how to be holistic, how to integrate these 5 topic areas into a regulatory framework. And to do that, our board of directors came up with a bin concept where you would have increasing regulatory actions as you had increasing 90th percentiles of your first draw 1 liter samples for lead. So 0 to 5 would be sort of the minimum you'd have to do. 5 to 10, you do more. 10 to 15, you do even more. And then above 15 had your most extensive regulatory requirements. So in pulling that together, then we looked at what would be the hours and then ultimately the cost for the state transactions for all these different components of the rule. So you'd have a regulatory startup that would be for the states to adapt their own regulation, to do training of the state staff, to do training and technical assistance for the water systems, to modify their data management system, then also to review and approve the different plans. You'd have plans for the materials inventory, you would have tap sampling plans, you'd have corrosion control plans, and not all these plans would be right the first time. So there'd be plans that would come in, the states would have to go back to the water system and get them to work on them and then review them again. There'd be a handful of systems that just would never get it right or not submit them, so you'd have violations. You'd have to bring those systems back into compliance. So we developed this cost of state transaction study that was included in our comments to EPA on March 8th, and you can find those comments that include this study on the ASDWA website. And this just gives a summary of estimated hours for these different categories. And so again, we have this, you can kind of look at, these different hours. We have a low and a high range because EPA proposed a range of corrosion control options. You can see the big difference on corrosion control treatment between the low and the high options. The other ones are all the same. And then we're able to take another state resource report, back out the current lead and copper rule hours in 2018, and come up with an increased workload for these revisions over the first 5 years. So therefore, if you take this number and divide it by 5 and assume a loaded rate of about $100 an hour for a staff engineer, then you can see that on the high side, the cost to the states would be about $101 million per year, which is coincidentally the amount of federal funding given to the states through the Public Water System Supervision Program. So again, this is just one, instead of a cost of compliance for the water systems, this is the cost of the state transactions. And we're gonna have this study available separately on our website in the next week or two. You can find it in our comments currently on the website. So again, then I came with this idea of having someone else to do the research, some interns, and you got to pick a project where the work can be done in the summer. So you have to have a manageable hypothesis. So these are the 6 papers that were published in the Journal of AWA. It shows the publication date. Steve Reiling on energy costs, Lauren Ware on cost of revising the nitrate regulation from 10 to 5, Craig Abashan on rates and water loss, Emily Vigathic on arsenic compliance, Catherine Alfredo on chlorate, and then Aaron Russell on water loss. So again, you could go to the AWA website, go to the journal, and Google these or search these last names. You could find all 6 of these papers. So again, I'll sort of close out with the recommendations. I think the time is ripe, given this regulatory slowdown in the EPA, for more drinking water policy research. Funding is a big issue. Who pays for these graduate students or interns? And then how do you develop the right ideas, and how do you manage the oversight of these policy researchers? Can we collaborate with more universities? I've been working with George Washington University for the last couple of years on their senior capstone projects. The students are currently working on the impacts of road salt on private wells in a small town in Connecticut. So that's one opportunity that may work with collaborating with universities. So again, if you're interested in working on drinking water policy, that's my contact information, both in email and direct line. So just to let everyone know, this webinar is going to be recorded. I hope it'll be posted on our website, so it'll be broadly disseminated. So just keep that in mind as you're asking your questions in the question panel. So now I'm going to turn it over to Dr. Maura Allaire. Maura did a postdoc at Columbia for the last couple of years, just landed at UCI in the fall of 2017, and she published a paper recently that I found very interesting and that proceeding to the National Academy of Sciences. So I'll turn it over to Maura. Thank you.
Thanks so much for the introduction, Alan, and thanks to everyone on the call for joining this conversation. So I'm Maura Allaire, and I recently started at University of California, Irvine, where I focus on water economics and policy issues. And the work I'll share with you today really focuses on the challenge of securing safe drinking water for communities across the country, knowing that we face issues of impaired source water, aging infrastructure, and strained finances at many water utilities. So I was really excited when this webinar was first proposed, since this is a great way to start a dialogue between university research and all of you who are actually making sure that communities across the US have safe water supplies. And so I especially look forward to the end of this to really hear your thoughts and reactions to this study, and to also hear your thoughts into what the top challenges facing community water systems are, as well as what role research might be able to play in addressing those issues. So I started this current study that was published last month, actually 2 years ago, when I was living part-time just a half hour from Flint, Michigan, when the water crisis there grabbed national attention. So like most folks, I was shocked and really became concerned about the state of drinking water quality for communities across the country. Because besides Flint, we know that there are several other major water quality issues that have captured national media, including those reoccurring algal blooms in Lake Erie, the massive Elk River chemical spill, and more recently in Corpus Christi, when that community had to issue a do not drink order because of petrochemical contamination. So we know there's a variety of factors that might contribute to water quality issues, and those include certainly aging infrastructure, impaired source water quality, as well as many community water systems that are struggling financially. And generally, water systems in the US do provide some of the highest quality drinking water in the world, but some communities struggle to meet those high standards. And compliance with the Safe Drinking Water Act hasn't improved much over the past decade. The EPA does have a strategic objective to achieve consistent compliance for 91% of the population that are served by community water systems. But over the past decade, compliance with health-based standards have ranged anywhere from 79% to 94% of the population served by community water systems. And in a typical year, anywhere from 7 to 8% of water systems have at least one health-based violation. So improved compliance is really critical to ensure safe drinking water nationwide. But improving the compliance is certainly complicated by considerable reductions in state budgets for enforcement. And given these dual challenges, new strategies might be needed, and perhaps some thoughts will come out of this webinar today, as well as in the further discussion that we'll have. But the idea behind this recent study is to target utilities that are underperforming. Perhaps this could be one way, one approach to improve compliance. And by identifying trends and violations and vulnerability factors associated with violations, perhaps this can shed light on which types of communities can benefit from greater regulatory oversight as well as assistance. So this is what, yes.
I'm sorry, really quickly. I just want to fix the display here for you really quick. Can you go to the dashboard?
Sure.
Right at the top, underneath the play or pause button, there's a drop down that says screen, and just select your PowerPoint.
Sure. Oh, okay, so show screen, PowerPoint. Okay, PowerPoint. Okay. Does that look better?
Let me see. Perfect. Yep. Thank you so much.
Okay, okay. Great. So all of these issues are really what motivated my latest study that provides one of the first national assessments of trends in drinking water quality violations across several decades. So these recent water quality crises raise questions such as how widespread are these types of violations, what might be spatial and temporal patterns, and last but not least, which types of communities might be most vulnerable to water quality violations. So to address these questions and to really start tackling these issues, I conducted a variety of statistical analyses to understand how violations have changed over time and how violations might vary across regions of the US. So the objective of this most recent study was to characterize the extent and severity of violations, and then second, to identify characteristics of water systems and communities that might be more vulnerable to violations. And perhaps then with this information, this could inform better targeting, not only of enforcement, but also of assistance efforts. So to do this, I had to combine several different data sets together. And so this included not only violation information from the EPA, but also utility characteristics that are also available through the Safe Drinking Water Information System. And then this was combined with a variety of demographic information from the US Census. So really bringing together these disparate sources of data to begin to address these issues. And I'd also like to clarify that the violations that I focused in on, I really just focused on health-based violations. So these include maximum contaminant level exceedances, as well as treatment technique violations, so water systems that aren't following through with established treatment procedures. So the important thing to note here is that this study really didn't include monitoring and reporting violations. It's only focusing in on health-based violations of the Safe Drinking Water Act. And in terms of the types of contaminants that were especially prevalent, over the past 30 years of the Safe Drinking Water Act? Well, it turns out that total coliform was the most prevalent type of contaminant, but disinfection byproducts, they weren't far behind. And then there were also quite high prevalence of a variety of treatment rules geared towards surface water and groundwater. So in total, this study captured over 95,000 violations from the early 1980s until 2015. So what did this study find? Well, one of when news about the Flint water crisis broke, there were over 34,000 health-based violations, and these affected about 9% of water systems in the country and affected up to 21 million people. But of course, this is the number of people served by the affected systems and not the number of people actually exposed to contaminated water. So when looking across a larger range of years, I also was very much concerned with how these violations were distributed across the country. So to begin to look at this, I started mapping out these violations. And at least this map shows for the most recent decade of the study period, so from 2004 to 2015, the numbers of violations per community water system in a given county. And so this map shows where violations might be most prevalent. And many factors could certainly contribute to these patterns, and certainly those factors include the quality of raw source water, as well as state regulations and enforcement, since we're well aware that there are state level differences in rulemaking as well as enforcement, since states are largely responsible for setting sampling protocols and overseeing water systems. So with this mapping, it appears that violations are especially prevalent in Oklahoma and parts of Texas, and the statistical analysis also backs up these findings. So besides, narrowing in on one particular time period, we can also map violations across time and begin to look at how these violations might be evolving across the past 30 years. And so generally what we see is that the numbers of violations appear to be increasing over time, but I'll focus in on that point later on. But when we focus in on the earliest decade, so that map in the upper left, in the earliest decade, violations appear to be prevalent in western parts of the US, but then by the 1990s up to the early 2000s, as we move towards the map in the upper right, then violations are becoming a bit more prevalent in parts of Idaho and Oklahoma and Tennessee. But then by the time we jump down to the most recent decade, then this is where parts of Oklahoma and Texas especially appear to perhaps be underperforming in achieving compliance with the Safe Drinking Water Act. But to really get a sense of how violations of the Safe Drinking Water Act might be changing over time, this graph shows numbers of violations from early 1980s until 2015. And so at first, it might appear that violations have increased considerably, but this is likely driven by the increase in number of contaminants that are regulated in the first place. Because when the Safe Drinking Water Act was first created, there were only 22 regulated contaminants. But this has risen to 91 contaminants that are regulated today. And we can also see that immediately after rule changes or new rules being established, we can see spikes in violations of those very contaminants that have had their rules being changed. So For example, in the early 1990s, we see this bar for the gray bar for the total coliform rule. So this is when the total coliform rule, the changes to it became enforced. And then immediately after this, numbers of violations of total coliform have this uptick. So this really highlights how important it was to control for these sorts of time trends and these year-to-year changes in rules during the statistical analysis, because we know that federal level rules are evolving, and so we need to be especially careful to control for these types of year-to-year working. Besides looking at numbers of violations for the nation as a whole, we can also start to break it down by regions as well as states. And so when we take a close look at what's happening at the regional level across time, we can begin to plot out numbers of violations per water system for individual regions. And all these regions are based on the US Bureau of Economic Analysis, their definitions of regions in the US. And when we do this, one region that stands out in particular is the Southwest. And the Southwest includes states of Arizona, Oklahoma, New Mexico, as well as Texas. And enforceable. There was an incredible uptick in the number of violations per community water system in the Southwest region. And so violation incidence in the Southwest is triple that of other regions. And we also see an uptick in violations as well in the Plains region, but the Southwest in particular stands out as having a quite dramatic increase in numbers of violations. And the majority of these violations in the Southwest are disinfection byproduct violations. And the Southwest might be especially prone to these types of violations since there are high summertime temperatures combined with high total organic carbon loads, and also the fact that some states, such as Oklahoma, they require an especially high disinfectant in their water. And these factors combined could perhaps contribute to these disinfection byproduct issues that we do see in the Southwest region. So besides looking at trends, we can also hone in on individual states and what might be happening to individual states across time. And so to do this, I looked at state-specific time trends and how they might differ from the overall national trend in violations. And so when I did this, states with particularly large increases in violations that really do break from national trends, these states include Nebraska, Arkansas, and there were a total of 20 states that had significantly higher increases in violations compared to what was happening to the US overall. And so these increasing time trends at the state level are especially worrying because we hope that things are improving over time. And so I think this in particular, there should be further work that explores why violations might be increasing in these areas and how we can begin to improve compliance, especially in states that appear to have higher than national trends in violations across time. And so I would especially love to hear your comments in our discussion regarding this, perhaps issues that these states with increasing time trends might be grappling with, and sort of what could be done to begin to address those types of issues. While this study did track how violations have evolved since the 1980s, we can look at, overall time trends and overall spatial trends. But one thing in particular that should be worrying is if violations are recurring year after year. And if there are water systems and parts of the country that have issues with repeat violations, then perhaps these should be areas that should be of particular focus for enforcement and assistance actions. And so luckily, we find that few systems have repeat violations. Only about 11% of community water systems have ever had a repeat violation in terms of having the same type of violation occur in subsequent years. But some states have actually a high portion of water systems with repeat violations. And Oklahoma in particular stands out in this regard as well. So Oklahoma has a large portion of community water systems with repeat violations, and it also has the highest number of systems with violations that reoccur for 8 or more years. And so there appears to be persistent water quality concerns in some parts of the country that perhaps aren't being resolved in a timely manner. And so these are perhaps areas to really begin to target and really think through what can be done to address these issues that are reoccurring year after year. So besides assessing how violations are spread across the country and how they're changing over time, I was also concerned about identifying the types of water systems that might be more vulnerable to violations. And so I did a statistical analysis to look at potential utility characteristics that might be associated with violations, as well as demographic variables. And I was also careful to control for years, because we know that rules are changing on a year-to-year basis, as well as the state that a water utility was located in, since there are state-level differences in regulation and enforcement. And so in this analysis, this was limited to water systems that were actually reporting their violations over the study time period. And it was limited to those water systems that were serving over 500 people, because those smallest water systems have substantially different monitoring and reporting requirements in terms of sampling. So the major finding that came out when narrowing down what are vulnerability factors associated with violations, it appears that rural areas, and especially rural low-income communities, were more vulnerable to violations. And this compliance gap began in the 1990s after the surface water treatment rule became enforceable, but there was a dramatic increase in the early 2000s after the disinfection byproduct rules. And so rural water systems, and especially rural low-income communities, there's certainly less technical capacity to treat water, because these systems, by definition, have smaller customer bases and therefore might have less financial resources available to them. And they also perhaps have less access to loans and outside financing to be able to afford upgraded treatment technologies, or to even be able to afford full-time operators. And so these systems in particular face challenges with complying with stricter standards. And besides this finding of rural areas and rural low-income communities struggling to meet stricter compliance standards of the Safe Drinking Water Act, the study also found that perhaps private utilities and large private utilities, perhaps these types of water systems are less likely to violate than other types of ownership arrangements. And one reason for this is perhaps they have a lot to lose since they face the potential, if they do not serve water that meet federal level standards, then they face the potential for lawsuits, or in the most extreme cases, perhaps face the potential for municipal takeover of the water system itself. This study also found that water source, there's a considerable relationship between the type of source water a utility relies on and the likelihood of violation. And in particular, purchased water appears to have less likelihood of incurring violations. And so perhaps this could actually offer smaller water utilities a cost-effective way of meeting stricter standards of the Safe Drinking Water Act, because purchased water contracts might offer a way for smaller systems to access a larger scale, larger economies of scale for treatment technologies. And perhaps this is one way to improve compliance among smaller systems across the country where those types of contracts are feasible. So this study had a number of interesting findings, but the question that remains is, what can we do about this? How can we go about improving compliance? And some possible ways forward, and I'd also love to hear your thoughts, are that, well, first, there likely needs to be a better understanding of the current state of U.S. drinking water quality, and perhaps advanced reporting and monitoring is one way to achieve this, because we know that 26 to 38% of health-based violations either aren't being reported or are inaccurately reported to the National Safe Drinking Water Information Database. And capturing a more complete picture is absolutely critical for furthering public health goals across the country. And so the EPA's new cloud-based reporting system that'll soon be rolled out, SDWA Prime, might allow for more consistent reporting across states. There also might be room for better recognizing the linkages between the Clean Water Act and the Safe Drinking Water Act to be considered in terms of regulation and enforcement. And this could especially address issues of source water impairment. So if violations of the Clean Water Act lead to greater treatment costs at community water systems, or if they lead to violations of the Safe Drinking Water Act, perhaps it's worth thinking through whether these two sets of regulations could work in tandem. And then a third idea that I've tossed up is that economists have often mentioned allowing for some variation in Safe Drinking Water Act standards across states. And perhaps this is one way of providing a more efficient way to handle water quality regulations, since this could be a way to represent local preferences and perhaps regulate location-specific concerns that wouldn't pass a cost-benefit test at a national level. And in terms of research priorities that I'm thinking about, but would love to hear your thoughts on what you feel are research priorities going forward, two main lines that I have in mind are, well, first, better understanding the full scale of the problem, and second, begin to think through how we can begin to reduce violations. So in regards to this first research idea for a research priority that I've tossed up, is that, again, we don't understand the full scale of the problem because there are so many unreported violations that aren't being reported to the national level Safe Drinking Water Information System. And so the thought here is, how can we begin to capture these one idea that I've had is that perhaps one way around these data challenges using federal data is to begin to assess consumer purchase behavior. So perhaps using supermarket records in terms of bottled water sales or anti-diarrheal medicines. So products that consumers would purchase when coping with water quality concerns. And so this work is being done with collaboration between Columbia University and the University of California, Irvine. And the idea here is to begin to analyze perhaps spikes in bottled water sales and spikes in over-the-counter medicine to begin to detect when unreported violations might be happening, and perhaps to be able to develop a tool that could rapidly assess quality concerns. And so this, and then the second line of research is to think through, well, what types of actions might be effective in actually allowing water systems to reduce violations? And so this involves a whole series of research that's continuing to look at what is the link between violations and utility finance, violations and impaired source water quality. And so beginning to collaborate with folks who model perhaps agricultural systems and industrial sources of contamination, and begin to link these things together, source water quality and violations of the Safe Drinking Water Act, as well as taking a close look at emerging issues, especially issues of extreme events that utilities are beginning to have to grapple with, and beginning to think through how can we build resiliency to these types of extreme events, especially when they could have sort of dire consequences for water quality across the country. So to wrap things up, I look forward to hearing your questions and comments and our discussion, and I'm also more than happy to talk offline if you have questions or are interested in discussing these issues further. And with that, I will close out, and I look forward to taking any questions.
All right, Maura, while we're waiting for some questions to come in, again, if you have any questions you want to post to either me or Maura, put them in the question pane. But I had just a couple comments and maybe one question. This is really great work, Maura. I've read the paper, but it's always nice to have a visual presentation because you get nuggets visually that you don't necessarily get when you're trying to read the peer-reviewed paper, which is quite good, by the way. It's just different. But I also like the way that you were combining data sets. That's one thing that I had one of my interns do on the arsenic regulation, where she looked at after a decade after the rule was revised, were systems that were still in non-compliance, did they have a lower median household income than systems that came into compliance using the census data. Mm-hmm. And she found that, yeah, there was a difference that was statistically significant, but not as great as you might think. In other words, one was like 42,000, the other was 44,000. I thought there'd be a broader gap. And so I think maybe some of the research that you talked about on utility finance might get into some other issues, because that's a complicated issue when you try and take a look at, not just the rates, but what kind of debt load does the utility have? How much are they investing in maintenance? That can be a problem sometimes, where a system will get some money to build some new components and then not maintain them, and 20 years down the road, you're in the same problem. So I did have one question about the vulnerability factors. I noticed in your slide you didn't look at systems that serve less than 500 people. Was there a specific reason for that? Was it just too much data, or the data had too much noise in it?
Yeah, the data was quite noisy once you went below 500, and also because there's different, substantially different sampling requirements for those very small systems. So in terms of frequency of sampling, so once you go down to 500 people, there's some types of contaminants that only have to be sampled on a quarterly basis versus monthly for larger systems that serve under 500 folks. And there's also evidence in the literature stating that monitoring and reporting at those smallest systems serving under 500, there's especially concerns once you get down to those incredibly small systems.
Yeah, that's a good point. I mean, even on some rules for the small systems, they can, and even this with larger systems, you have it on the text, they can waiver out and go to every year, or every 3 years, every 9 years. So sometimes the data can get pretty sketchy, but if they're not finding it, then it's not really an issue with violations. But you're right, the monitoring frameworks are quite a bit different. The other question I had is just maybe it's more of a comment. Again, given my time at the American Water Works Association, I was involved in both the negotiated rulemaking on disinfection byproducts, as well as one that's done for revised total coliform rule. And the revised total coliform rule, the idea is that you'd actually have less violations, and I'm not sure that we're seeing that now. DBPs, we had some idea that consecutive systems would be a problem, but not as many. And so, you know, I don't know what the answer is. It's just more interesting that we're seeing this consecutive system and more issues with DBPs than we might have thought when we were trying to work on the rule in the 90s.
Sure. I mean, I think there's always a period where water systems are, you know, being handed a set of new regulations, and then it sort of takes time to get up to speed. But it appears, at least in the case of disinfection byproduct rules, that perhaps there's some parts of the country that are having an especially long period in bringing those systems up to speed to be in consistent compliance with disinfection byproduct rules.
Yeah, and I think that's going to be a challenge for many years. And so we had a question come up from Karen on disinfection byproducts, so I'll go to that. So, you know, if you recall, the original THM regulation only applied to systems serving greater than 10,000. And so when the stage 1 rule became effective in 2001, you know, you were going across multiple decades. You know, how did you take that into account, or was that just, you think the reason you saw the big spike is we had all these systems that were unregulated now getting kicked in?
Sure. So I mean, I would say, you know, first I was, you know, simply plotting out the raw data, and this is where we see all those incredible spikes on a year-to-year basis. But that's why it was so important once I headed towards the statistical analysis that really formed the basis for the conclusions that came out of the report. In that analysis, I was then controlling for those year-to-year changes in federal level rules, because we do know that rules are changing. The standard that water systems have to meet, they're changing over time. And so, you know, we want to make sure to control for those types of year-to-year rule changes, and just so to be able to, you know, take away those types of trends to really narrow in on, okay, what's actually happening at the water. We do have federal rule changes.
So I got a question from Michelle in a state that will remain unnamed. Was asking if there was, because of course, you know, my members are states, and so I don't want to point a finger at somebody, but the question is, was there a correlation between the higher violating states, such as Texas, Oklahoma, Nebraska, and the prevalence of the small rural systems in those states?
Sure. I mean, I think these factors are certainly related. And in particular, Texas has an incredible prevalence of small water systems. That was particularly a defining characteristic, I would say, of Texas. So certainly these things are connected. And so, you know, as well as having an incredible prevalence of rural systems. But it also appears that perhaps something is happening on a more systematic basis, perhaps especially in Oklahoma, because it's not only the rural areas, but it appears to be urban areas that might have these types of persistent, reoccurring issues as well. And so I think certainly digging down into those findings to really tease out, what is happening in parts of Oklahoma and parts of Texas, and how can we begin to actually solve these problems, right? Because especially in Oklahoma, it wasn't just a series of one-off events at a variety of community water systems, but there it seems that year after year, perhaps there's the same types of issues reoccurring. But certainly there's a variety of factors that come together to create these conditions.
Yeah, and then Maura, just to in the interest of self-disclosure, I grew up in Oklahoma, and my mom lives in Texas now, and so those states are both like a lot of the Southwest is geographically challenged. There's a lot of distance between these communities, so consolidation is challenging. And sometimes when they do consolidate, then you run into that consecutive system issues, because now you've got long pipelines, higher water temperatures, and so then the DVPs become an issue. So it's a real challenge when you get into these areas where you say, well, you can consolidate with the next system, and it's 20 miles away, and it's a challenge to run a pipe so you don't get some ridiculous residence time. So anyway, it's just one of the challenges when you're trying to use the limited data. I mean, that's one of the issues that you can also extract from the study that you did, is that there's really not a lot of different data sets you can combine and try and look for these correlations. I got a comment from John, another academic, that said, it'd be interesting to try and capture the change in the DBP levels over time, which has been done a little bit through a paper that Mike McGuire published, where you looked at the pre-THM concentrations, the median, the 9th percentiles, the post-THM rule, and the predictions that we did for both stage 1 and stage 2. And you can see where the median and 9th percentiles have both been, particularly 9th percentile, got a big drop, and that you were getting rid of those tails with the high concentrations. Now, in the process of doing that, you've tightened the standards, you've created more violations, but you may have actually improved public health and decreased exposure, and that's a harder thing to capture because we don't have the actual concentrations on all these numbers, we just have the violations.
Correct, yeah, and that's one issue I certainly grappled with, because we just have this just a binary indicator, yes, no, did a violation occur, and not having sort of more detailed information of, okay, this did, pass some threshold for either a maximum contaminant level, or a water system wasn't meeting a treatment technique, but we don't know the extent to which a water system was in violation.
Yeah, and then there's other regulations. The arsenic is one that I did a lot of work on back in the day when they lowered that regulation from 50 to 10. Then a lot of systems got picked up. There's still a lot of challenge for these systems that serve 100 or 200 people that are at 20, and the treatment's just very expensive to put in place and then also maintain. You've got to either change the media or whatever it might be, and so the operation and maintenance costs are pretty high. It's going to be really challenging for small systems. So that appears to be our last question. If anyone wants to continue the dialogue with either myself or Maura, you have our contact information from the presentation. And something I've thought about is we may start a sort of an informal dialogue either at one of the AWA conferences. Maybe we'll have a breakfast at the annual conference in June to try and kick around some ideas on how we might make this idea of water policy research become a little more standardized throughout universities, because again, I see this policy research on other environmental economics. So if you look at fisheries or forestries or transportation, a whole lot of other issues, we have a whole body of policy knowledge that's lacking in drinking water. And given the additional focus that we're seeing on drinking water quality, I think it's important that we try and continue this conversation. So again, thanks for participating, thanks for listening, and let's keep the water safe.